If I could ask you guys a few questions before we get started. This is going to be about 55, 60 minutes of ideally kind of weird Git internals stuff. That's what I'm intending to do. I hope that's what you came for. So just kind of curious as to your level of comfort with Git. Is there anybody who's totally new to Git, like complete beginner? Don't be shy. Yeah, it's totally new, totally new. Anybody else totally new? I'm going to be, there you are. All right. I'm going to not treat you well. And it's not that I want to treat you poorly, like you know, but you understand, you've been warned. This is not how I normally teach people Git. This is sort of some internals and some extra insights about Git that can be fun to have. And actually, my experience, and I have a lot of experienced people teaching Git. That's my job. I work for GitHub. I'm a part of the training team. So I go to conferences and give talks on Git. I visit enterprise customers and give 2 and 3 day classes, or 1 and 2 and 3 day classes on Git. I do this a lot, and my experience is when people start to see, when developers start to see some of the details under the covers, things start to click. All right, I watch this happen. I watch the light bulbs figuratively appear. I want to say literally appear, but that would not be true. Figuratively appear over people's heads when some of this stuff starts to happen. So I'm going to do that. I'm going to give you some internals at the beginning, and then we're just going to kind of play around with some other interesting, moderately advanced Git topics that most people don't feel super comfortable with. Okay? If you've got questions, and I appreciate that we are uniformly distributed throughout the room. I mean, we wouldn't want to be all in the front so that we could like relate to each other. So well played there. If you've got questions, basically, if you're in the back, you have the advantage of being able to sit in the back. There's like no way I'm going to be able to hear you. But try. I would love to talk. It's more fun for this to be interactive. But if that doesn't happen, if I appear to be in transmit only mode, we'll have a good time. That's what I can promise you. Also, fun fact, this talk ends at 12:25, right? My flight out of SJC is at 2:10. Now that can be done, but if I appear to be in a hurry at 12:25, that's not because I don't like you. It's because I like my flight. So let's start with something really basic. I told you this is internals. Let me show you like the proper and respectable way of creating a Git repository and adding a file. So you 4 people who came to the advanced Git talk without any Git knowledge, this is your lucky 3 minutes. All right, if you want to create a new Git repository and you're a normal person, you'd do something like this. You'd say git init jax, and that would make this directory called jax, which is a Git repository that has this hidden folder called .git that has all that stuff in it, right? Maybe you've ever looked at that stuff at some point in your life. Maybe not. It's not there anymore. Well, then you'd create a file, okay? You'd create a file maybe like beowulf.txt, and we'd say, so the spear Danes in days gone by had courage and greatness. All right, and then you would add beowulf.txt. You'd say, okay, there it is in my staging area. Command line completion gone awry there. There it is in my staging area, and you'd make a commit. Okay, and that'd be cool. So that's like the basic nobody gets hurt way of starting a repository. So interesting things happen in .git when I do that in that folder. All of a sudden that objects directory has some things in it. And if you're looking really closely, the bottom directory called refs used to just have a subdirectory called heads and tags, and now there's a file called master in there because I'm on the master branch. If you've ever looked at what it means to be a branch in Git before, you've probably seen that those files are down there. If you've ever taken an introductory Git class from me, you've certainly been pointed to those files. So stuff happened, and we've got a history. And in fact, at this point, status is very happy. It says everything looks great, and log also is willing to talk to us about what I just did. So that's the normal way that somebody would do something like this. But I don't really want to. I honestly, I think that is way too mainstream. So what I'm going to do is blow that away, take that Git repository away, and we're going to do this piece by piece. I'm going to show you Git commands that most of us never have a reason to use at all. Okay, you say, well, wow, Tim, that's pedagogical genius. Show us something we don't need to know. But the process we're going to go through is going to show you some things about how Git is put together, and there are, frankly, software design insights to be gained by looking at Git on this level. So it's useful to know Git as from the bits up, as the title of the talk says. There are broader insights that'll make us better developers if we internalize them. And this is going to expose you to kind of an internal Git API that's there for your use. And things can come up, situations can come up in the real world where you might need to use this stuff. And it's there if you need it. So if you want to be that person on the team who's the Git weirdo, I'm a professional Git weirdo, so I understand you. But if you want to be that person, you're going to need to know this stuff. So let's jump in. All right. I am in a working directory. That's great. I'm going to make a directory called Jax. And that's going to be my new Git repository. Let's ask Git if that's a Git repository. Git says, no, you don't have a .git directory. OK, so let's make a .git directory. And Git is still not happy. So it's not enough just to have a .git directory. There's stuff that needs to go in there. And the stuff that needs to go in there are kind of two basic things we're going to create. And those are the two basic things that a Git repository fundamentally is. A Git repository is a collection of objects and a system for naming those objects. All right? It's a collection of objects and a system for naming those objects. The system for naming the objects, in Git we call those refs. So to be a Git repository, we need objects and we need refs. Lots of other stuff we might have. We might have configuration. We might have hooks. We might have a description. I don't want that. We don't need any of that. We need an object. Objects. We need refs. Let's make those things happen. So let's see. I will say, well, make dir underneath Git, a directory to hold the objects, a directory to hold the refs, and refs are, again, names for objects in a Git repository. There is a moderately detailed language that we can use to describe refs and refs with relation to one another and so forth. That is the ref spec syntax. Probably, I'm just guessing, kind of classroom time, like a full disclosure of all the details of the ref spec syntax, 4 or 6 hours, long time, okay? And nobody would sit through it. It's a thing that you pick up a piece at a time. But the ref spec syntax, everyone here has used if you've used Git. We need refs. Those are those names for objects. Refs are, that's what I was trying to say, a generalized namespace. The particular kind of refs we need are what Git internally calls heads, what normal people call branches. All right, I've got a place for objects. I've got a place for refs. Starting to look something like a Git repository. Status is still absolutely not impressed. Well, it's going to take a little bit to make status impressed. I need to add a file. I am not going to use VI or any conventional text editor to create that file. Okay? I'm going to use echo. This is a commit using echo and commands, Git commands you've probably never heard of. For example, in just a minute, I'm going to need to use a command called #object. #object, helpfully, computes an object ID and optionally creates a blob from the file. So what this is going to do, #object, I'm going to pipe some stuff into it. It's going to compute a SHA-1 hash of that stuff, and then it's going to write that object into the objects database as something called a blob. So stick with me here, and I'll do it. Oh, wait, before I get started on that, this pane, remember this pane I left over there? Because my display is being a pain and not letting me mirror. Let's see, let's clear, let's do a tree of .git, and let's sleep for a second, and let's be done, and we were in the wrong place for that, so all right, here we are. We will clear, we will take the tree of .git, we will sleep for a second, and then we will be done. Every once in a while, somebody says, hey, don't you know about the watch command? Were you thinking that? Okay, the answer is yes. I do. What'd you say? It's yeah, it does some things that I don't quite like. Anyway, we're now looking at the content of the .git directory as I change it. Let's use hash object and see what happens to us. So like I said, I'm just going to use echo to get that same text out. So the spear Danes in days gone by had courage and greatness. We have heard of these princes' noble campaigns. That is the opening line of the Seamus Heaney translation of Beowulf. Swedish on my father's side, so it just feels right. All right. Echo. That's my text. I'm not going to use a text editor. Instead, I'm going to pipe that into hash object, and I'm going to ask hash object to take its input from standard in, and I'm going to ask hash object to write its results to the object database. I don't want to just hash the thing, but I want to write it into the object database. So let's watch what happens when I hit enter. And why would you say that? I'm in JAX. I have sometimes the best laid plans of git refs heads objects.git. Yeah, no, that actually works. So the not working you saw a minute ago was something that didn't happen. Well, that's interesting. All right, let's solve this problem together. We'll look at the help for hash object, and that takes input from standard in, which I have piped and has -w, and that is a little bit of a bummer. I don't know if this is a matter of the recent update to Git I have installed, that there are separate expectations. So here's what we're going to do to save your time. I'm going to get up there, and I'm going to rm jax, and I'm going to git init jax, and we're going to do that in a slightly less hipster way. Now we'll see that there's a bunch more stuff in there, which I will clean out. So for example, I will take away hooks, because they're a little wordy. I will take away the description, and that'll be enough. So let's just leave it at that. All right, once again, git, pardon me, echo. So the spear Danes in days gone by, let's clear this. And we see Git is much, much happier. All right, when I did that hash object, I'm going to have to re-prototype a couple of things here because behavior of hash object has changed since 1.8.1. I'm running on 1.8.2. That's embarrassing, dang it. But here's what I want to show you. Under the objects folder, we get a new directory called B0, and under that, a file that's named for a hash. Hash object also gave us the hash of that thing. So you kind of see the way that hash is mapped into that directory. Objects is essentially a big giant key value store of all of the objects that the Git repository is composed of. But since if you store those as loose objects, at a certain point, any given file system is going to get mad at you for having too many files in one directory. It will not perform well. Git is just dividing that problem by 256. It's taking the first two characters of that hash and making that the directory name. So objects always has 256 directories, which all have now potentially a large number of loose files in them. Now, in the real world, if you go looking in your .git directory and you don't see a whole lot of loose objects, even though you've got a big project and a long history, that's because of that directory there called pack. The pack directory will handle packed object files, which is, as they say, a whole nother thing that we're not going to talk about. That's another layer of optimization that's just not important to us in the scope of this talk today. All right, but we need to talk about the blob. That blob contains the content we just echoed into it, and I've got a command that I can use to look at that. I could say, would you please pretty print, or print, the content of blob B0D9C44. That's enough. That's enough that that is unique. Actually, I could have gone with just 4 characters. Git would have taken that. But that object holds the content of that file. And that's how all files are stored in Git. Every time you change a file, the add command, when you add that file to the staging area, is creating a new blob with an absolute snapshot of the whole file. It's not storing just the changes. It's storing everything. You change 1 character. If you think about it, you're going to hash that new stream of bytes. You're going to have a different hash. It's a different blob, and that blob gets stored. How do I know that that object is a blob? Well, number 1, because I said so, and because I can ask. I can ask, and Git will tell me it's a blob. And the other question I can ask is how big it is. It's 112 bytes long. And that's all the metadata that's in good old B0D9C44A312 etc. That's it. Size, blobness, and the bytes themselves. Beowulf.txt, I haven't said anything about that. There is no file yet. There's just a blob. Let's see what status says. Not much. Status says not much. OK. Now I need to stage it. I'm going to use a command called update index. Now, index, if you've nosed around the Git documentation a little bit, you have noticed that sometimes the thing that guys like me call the staging area, hopefully you call the staging area, is referred to as the index. That's kind of an old term. Staging area is the convention now, but originally it was called the index, and still in the documentation, and certainly in the implementation, it's still called that. So update index is going to write the fact, assert a fact into the staging area. I don't have a file to stage there, but I will say I have something to add, and I'll give it, oh dear, one thing I'll need here is my hash. Let's go back here, update index, add cache info 100644, and then the hash, which is B0, all that stuff. And then I have to tell it the name of the file, because a blob, again, doesn't have any file name. Now, when you add a file, you make a change in Git, you add it, it goes into the staging area, it's being prepared to be committed. That actually is taking a snapshot of that content and remembering the file name, remembering the directory it's in, remembering its file mode, which in this case I'm giving it 644, so it's read, write, and read to others. And when I do that, the directory doesn't change at all. But suddenly, status says, oh, well, I've got a file stage. It's called beowulf.txt. It's showing up in green. It's also showing up in red because why? The file doesn't exist. So suddenly there's this tracked file called Beowulf, but there's no tracked file called Beowulf in the working tree. And so Git thinks, oh no, this file doesn't exist. You've deleted it even though you've staged it. So we're in a little bit of a confused situation right now, and we need to move forward. I need to create a second object. It's not enough just to have a blob, but that blob is content that lives in a directory, in a file in a directory. This is the data model of Git at the level of a single commit. The file contents are stored in a blob. A tree object stores the file name, the file mode, and represents a directory. And right now, this project, the intent of this project is for there to be one directory with one file in it. So we're kind of getting there. Now, I need to remember this time to copy and paste that hash. I'm going to need that. But of course, I can use my good old friend catfile to ask what type of thing that is. And catfile says that's a tree. And I could ask how long it is, but it doesn't really mean anything. I could print out the contents of that tree. And if you look carefully at that, we see, OK, the first thing is a mode. This is like a directory listing. The second thing says blob. The third thing is the hash of the blob. And the fourth thing is the file name. This is just a directory listing. Now, if I had subdirectories, I would have something there that's a tree. And the content hash would point to another tree object. So I can represent a snapshot of the whole project right here. All right, so I've got the tree written. Status doesn't care at all. What I need now is to create a commit. These are the three fundamental objects that a Git repository is composed of. I said a Git repository is composed of this object database, this big giant key value store, plus refs, plus names for the objects, okay? The three kinds of objects you need to know are blob, tree, and commit. Blob is file, tree is directory. Commit owns that. Commit says this is a snapshot of this project at this point in time, written by this person at this email address at this time in this time zone with this message descended from this parent. That's kind of all the metadata of a commit. As soon as I hit enter here, we're going to see the third object popping up. Git is good enough to give me that. Now, if you use Git, you know that sometimes you see these hashes, like you see right down at the bottom there, 3D09. I mean, those are all very familiar looking. Almost all the time, you don't care about the tree hashes and the blob hashes. You're looking at commit hashes. But that commit owns a tree, and that tree owns other trees and blobs. That's always the case. When we do log in just a minute, 3D09 is what we're going to see. All right. And let's see what status has to say. Status is happier. Here, let me clear that screen. Okay, status is still not entirely happy. I wonder why. It still doesn't really think the commit has taken place because we're not quite done with our refs. Now, there's one ref, if you use Git, that you've used. You probably didn't think of it as a ref, but it's the word head. Head refers to kind of the commit that you're on. It's like the most recent commit, the last one. It's going to be the parent of the next commit you create. All those things are true about the head. And we do have a head. If you look right at on the right, .git, there's a head. Let's look what's in there. That's what's called a symbolic ref. Now, the head points to a commit, and right now, status is confused because it doesn't really know what commit it's pointing to. A commit hasn't really officially happened yet. Head is just saying, I don't actually know the hash of the commit I'm on, but we're on the master branch. That's called a symbolic ref. And that's a good way for your head to be. If your head actually contains a hash, then that means you are in a rather uncomfortable state called the detached head state. And that's not as bad for Git as it is for you. Generally, you can only have a detached head once. There's no really going back. With Git, that is an okay thing to do, but what that means is you shouldn't make changes. When you're in detached head state, that's sort of a read-only way of looking at the repository. This shows us Git thinks we're on the master branch, but there isn't anything there. Let me zoom in kind of on the refs folder. See right there? There isn't anything called refs heads master. We need to put something there. Now, do I have? Yes, I do. I happen to have that commit hash. Let's just check that out. Git cat file, print that out for me. Now that's wrapping a little bit, but if you can see what happened after I did cat file, it lists a tree, an author, a committer, and then it says initial commit. That's actually what a commit is. And the log command is always taking that data and interpreting it in some way. When log is representing commits to you, it might be reformatting that data in a more friendly way. That thing right there, that object is a commit, and we need to tell, I need to put that in .git refs heads master. Because part of committing when you're on a branch, and if you're not on a branch, if you're in detached head state and you commit, you're doing it wrong. So part of committing when you're on a branch, like a good citizen, is moving the label of the branch forward to the new commit. Now, there hasn't been a previous commit, so we're creating that branch label for the first time, but I need to do that. I just spat that text, that hash, into refs heads master. And that fundamentally, at the lowest kind of bit level, that's what a branch is. A branch is 41 characters, 40 characters of SHA-1 plus a new line, in a file under .git refs heads. And the name of the file is the name of the branch. So right now, status is almost completely happy. There's nothing in green anymore. Status thinks the commit has taken place. In fact, log now agrees that the commit has taken place. So we're almost all the way there. By the way, that let's see, that cat file right there. Looks familiar. The raw log format is basically doing the same thing as cat file and just giving you a nice yellow commit header on top of it. All right, my problem now is that I don't have the file. It's gone. One last step. Normally you use checkout to switch between branches. You say git checkout feature branch, git checkout master, and that moves the head over to that branch. And if you looked in the .git head file, you'd see it change. It's also going to rewrite the working tree so that all of your files in the directories look like the trees and blobs in the commit that you just checked out. Okay, so it changes the working tree and changes your head, and as it were, puts you on that branch. So that's kind of core checkout functionality. Well, I'm checking out the head, which is sort of redundant, right? That's like saying, switch me to where I am right now. But I'm giving it that dash dash. Now, that dash dash with no switch, no parameter after it is kind of a repeated idiom in Git. You'll see that from time to time. That separates the rest of the command. It separates what follows from any of the switches and parameters that came before. It says, however it is you were normally going to do your thing, do it, but just do it to these files. So like if you log in that way, log dash dash beowulf.txt, instead of showing the whole history, log interprets that as saying, well, I'm only going to show you commits that have this file in them. Or say you have a diff where 20 files are different, but you just want to see the diff of one. You could say diff dash dash that file name. It'll say, OK, I'll just show you that file. So every command is different in the way they interpret this. Checkout says, I'm not going to try and switch branches or anything like that. I'm just going to reach into the referenced commit, get that file, pull it out, and dump it into your working tree. So if you knew there's some commit over in a branch and you don't want to merge the branch and you don't even really want to cherry pick the commit, it's too messy, but there's this one file that you need, you can use checkout like this to reach into any commit, grab the file, and pull it out, throw it in your working tree. And with that, we have Beowulf and status is happy. We have finally, over the space of like 20 minutes, done a single commit. So why are these things here? And why do this exercise? Number one, I think it's really helpful for you to know that at each commit is a tree, in the data structure sense, composed of these tree and blob objects representing a snapshot of all the files underneath that commit. There are a lot of implications to that architecture that we could talk about if it was just us around a table. Interesting things go on as a result of that. But I want you to know that. I want you to know that that's how Git is put together. For me, when I was learning Git, that was a big deal. Just light bulbs went on. All right, so that's one thing. Number two, hash object, write tree, commit tree. What is this business? Well, these are called plumbing commands. The commands you normally use, like init, add, status, diff, log, branch, checkout, rebase, reset, push, pull, fetch, those are all called porcelain commands. These are Git's terms. I did not decide on the bathroom analogy, but the user interface in a bathroom is composed of typically porcelain, maybe stainless steel, or marble if you're into that. But let's just go with porcelain. That's the part that you touch and use. Now, that is supported by and composed of plumbing on the back end. Usually, you just deal with the porcelain. Most people just deal with the porcelain. If you are a professional, like you're a plumber, well, then you deal with plumbing all the time. If you are doing an addition on your house or remodeling your bathroom, maybe you'll deal with the plumbing. If something breaks, maybe you'll have to know how the plumbing is put together. So for most people, the plumbing commands in Git, and that's, I would say, kind of my taxonomy of plumbing and porcelain, 80% of Git's 145 commands are plumbing. Most people don't need to know them. But it's good to know that they're there in case you need them, because you can get below the level of the high level of abstraction, very functional add, log, status types of things, and do very fine-grained operations on things. And these are all documented. In fact, the help the man pages for things like write tree and hash object, look at that, it's done. I'm going to hit space, seriously, twice. If I get help for a porcelain command, because plumbing's hard, right? It's for experts. Porcelain's easy. So let's get the help for, I don't know, log. It goes on. Okay, so and it's got pictures in it. Look at that. The porcelain commands are much more functional, much more complex, do more, but you ought to know that the plumbing commands are there because, and here's the software design lesson. It's a good idea when you're creating an API, and by the way, that is how I describe Git, as an API for doing version control things. It doesn't have a workflow, it doesn't have opinions about how you should branch and how long branches should live or anything like that. That's up to you. Git's not going to make those decisions for you. It's just this toolkit, this API, for building your own collaborative workflows. Now, when you're building an API, just think at the level of code, all right, you pick some abstraction of the world that you're going to expose. And the abstraction is a lie to some degree, right? It's a simplification of what the world really is. But you have to do that. You pick some convenient simplification of the world, you represent that in code, and you publish it. You document it, it works, here you go, here's the API, you release it to the world. People use the API, and they start to say, well, here's an edge case you hadn't considered. I need the API to do this thing, and it doesn't. And what do? Well, if you're an undisciplined API developer like me, and you like to make people happy, then you say, well, of course, let me add that. You'll add an overload to a method, you'll beef up some data structure that the API passes back and forth, and things get a little more complicated. And that happens again and again and again, and after a while, the API is very brittle, very hard to learn, very complex, and you've got these 15 parameter methods that you thought were a good idea at the time, and complex classes that it's moving around. It's just hard to understand. Bad plan, all right? A better plan is to keep some discipline about that top-level API, and this might not look like discipline to you, but trust me, it is. Keep some discipline about what work that top level is willing to do, but implement it out of a lower level API. Entirely, make sure the plumbing is composed entirely of the porcelain, and document the porcelain. It's a good way for us to build systems. It's how Git is built. All right. Well, that's it for the internals. We kind of can do anything we want at this point. This view of the tree, or the Git directory, is actually going to get really annoying at this point. So I'm going to use a script I have called log live that will just give a automatically refreshing one-line log so we can sort of see some things that are going on. It'll wrap a little bit, but it's okay. Now, if I could just look, trying to get outside of the light so I can see you. Who rebases with confidence? There's like 2, 3 hands. It's not many hands. Good for you. The rest of you, let's learn. Now, rebasing is often confused with merging, and it's really a very different thing. So let me just kind of give you an idea of what's going on here. I've got my one file, beowulf.txt, and shamefully that's actually all I know of that, so we can't go any farther there. So we'll do something else. Let's see, we need to go with Edgar Allan Poe. That's a good choice. All right, so I need a little bit of content in my master branch. I'm going to have some content in my master branch. I'm going to have some content in my feature branch. Of course, I don't have a feature branch yet. That's okay. We'll come back to that in a minute. Let's just do this. And I'll say here, I'll say, distinctly, I remember it was in the bleak December. And I'll save and quit. And I'll add that file. And I'll commit with bleak. And there we go. The log updates automatically. Now, I need to have a branch, now don't I? I need a feature branch to be able to show you how rebasing works. I need to quickly remind you of what merging is, and I'm sure many of you already branch and merge. Work with me on this. Of course, what I want is a branch prior to master. I don't want to branch from where I am right now, and that's okay. I don't have to always branch from the head. I can branch from some other place. For example, 3D09, I could do that, and that will put that branch right there. Another cool trick you may not know, head caret. That means one commit prior to the head, the parent of head. And head only has one parent, so that's unambiguous. If I wanted to go back like 5, obviously in this repo that's not going to work. I could say head tilde 5, and that would work. I'm going to say head caret, and that's going to throw that feature branch right back there. No, it's not. We're going to reforce that to go here for reasons I will be happy to explain later. And Raven is going to have to get another commit. I was about to do something bad to myself, and you didn't see it happen, so that's good. I was in the bleak December, and each separate dying ember wrought its ghost upon the floor. Ember. Now, master pulls ahead a feature. I can go check out feature. And I can go in here and add a title in the feature branch. Now, conventionally, I would want to be back on the master branch, which I am now, and you can tell just by looking at the log. Head is on master, head's not on feature, so I'm on the master branch. To merge, I would just do that, merge in the feature branch, and that creates a merge commit, and that's fine as long as that's what you want your repo to look like. Rebasing says, you know what, I don't necessarily want to have to create a merge commit. In fact, you know how I was kind of thinking through, you saw me think, wait, where should my branch be from? Should I branch now? Should I branch later? And I'm kind of, at this point, I'm saying, I don't like that thought process. I think I branched at the wrong time. Or in any event, I wish, rather than branching 2 days ago and doing all this work, while all these extra commits happened on master, I wish I could just branch from master right now and have Git automatically rewrite all my commits on top of master. That's what's about to happen. That's what a rebase is. This is a merge right here, and I'm still going to need to merge, but I want to rebase first. And rebasing is a great way to handle this. Now, I don't want to have to type out more stuff, so I'm going to show you a way that I can undo that merge with a command called reset hard. Now, reset comes in 3 different flavors, soft and hard and famously mixed. A hard reset is going to change where the head is. So the head, I'm on the master branch. It's at AB09ED9 right now. I want it to be back where master was before I did the merge. And you don't have to shout it out, but if you could look at the screen and get an idea in your head, make a prediction about which commit you think that is. Where was master before the merge? There's basically only one possible answer. And that is, I don't know what your answer was, but I'm going to tell you the right one is B7FDA2D. Ember, the commit called Ember. That's what master was before the merge. And so if I want the merge to go away, I will simply say, let's reset to B7FA, which is reset. That's an FD. Thank you, guys. FDA. FDA. It's a government agency. All right. And now it's like the merge never happened. So what happened to that commit? I wonder if I looked in my objects directory, if I still, and I didn't note what the merge commit was. I should have. I wonder if I looked down in the objects directory, if I could still see that prior commit there and the associated tree and blob objects with that commit. The answer is yes. It's actually still lying around. And so reset can be a very dangerous command, all right? Number one, it rewrote my working tree. So if I had uncommitted changes in tracked files, those just got blown away permanently. All right, there's no way to recover those uncommitted changes after a reset hard. So that's a little dangerous. But it can also be dangerous in that maybe you reset to the wrong place, or maybe you were on the wrong branch when you did the reset. I've done that in front of 400 people before, and you have to have some way of rethinking the problem and fixing it. Now, I wanted to do this reset, but let's say there's a possible world in which I'm upset about that. I want to get that lost commit back, so I look at this thing called the reflog. Super, super, super strong sauce here. If you don't know about the reflog, you're going to be glad that you did. The reflog isn't a list of commits. All right, that thing over there that I've got in the pane on the right is not just a list of commits, it's actually the graph of commits rendered, and technically that's what the data structure is, that the commits form together. The Git repository is a graph. Reflog isn't trying to spit those out, it's giving me a list of the changes that I've made that have caused commits to change in some way. So if you bring a commit into existence with commit, that gets reflogged. If you back up over a commit with reset, that gets reflogged. If you merge a branch, if you check out, if you rebase, anything that's going to cause refs to change gets reflogged. And this is so powerful because I left AB07ED9. That used to be my, my merge commit. Well, I can go back to it if I want. Now my merge is back. Now, I don't want that. Okay, what I want to do is undo. So I'll do this. This usually means go to the most recent thing. And so I will. And now I will show you a rebase. I don't want to merge. I want to rebase first. Now, as I said, let's suppose that my frustration is I don't want to have branched from Bleak. I want to have branched from Ember. I don't want my branch to look like a branch. I want to look like I just instantaneously did all this work right now. And that's what rebasing is going to do. It's going to pull up. In this case, we only have one commit in each. I could have 100 in each, and it would work the same. It's going to pull up all the commits in my feature branch and rewrite them on top of master, so that master is the parent. And in the process, the hash is going to change. It's not going to be 0016A2C anymore. It's going to be something new. And if you think about the fact that the commit, the way you get the commit hash is by hashing the raw contents of that commit object, well, the contents are going to change. The parent is going to change. The tree is going to change. It's a different commit. So rebasing rewrites commits. Now, the syntax here is very simple. I want to pick up my branch and move it over to master. And so it is. It's done. So there doesn't look like there's a branch anymore. And if I get on it right now and nobody else commits to master, I can go merge feature into master, and I'll keep this nice straight line history. Really cool. So this is actually a controversial topic. Check out master, merge feature. This is going to be what's called a fast forward merge. So if you'll count, I have 4 commits right now, and the head is 2 something that I can't quite see. And here, let's do this for me. Merge feature. The head is 20EB77F. Master is just going to move up to point to that now. That's what's called a fast forward merge, where we just have to move so there's nothing in the branch that isn't already in master. I'm on master, I'm merging the branch into me. Git knows it can just move master up to the head of the branch that I'm merging. Guaranteed to work. Merge conflicts are impossible. No new commit is necessary. It's a very clean kind of merge. And that's what rebasing buys you. The broader story of rebasing, so there are 4 hands I saw when I asked before, people who do that right now. The broader story is complex and borderline political. Interesting tribes form in the Git community around whether this is a good idea or a bad idea. And you can find that discussion online, or if I ever see you at a longer talk or a workshop, we can have that discussion and really think through the implications. But this is certainly a good thing in that it keeps history straight. It does have some consequences about what sort of collaboration you can do on branches, when you can rebase, whether you have pushed commits before. You know, if I had shared the commit that existed before, the 00 something, and then I rebase it, I rewrite it, you know, that can be difficult for other people to deal with if I had already pushed that up to GitHub. So it's a big topic. And we'll leave it at that. So there we are. Now, got a few more minutes. Done at 12:25, right? We should probably do an interactive rebase, because I like interactive rebases, and they seem similar to rebases. So I'm going to keep my feature branch around. That's a little bit sloppy, but let's just do that. I am now on the feature branch. Excellent, excellent. Now, let's suppose I'm one of those people who likes to commit a lot. Now, in the real world, I'm not. I'm one of those people who probably needs to commit a little bit more frequently. I don't mind admitting. But what I need to do is I need to generate some random changes, and I'm going to make 10 files called random12345.txt and commit them one at a time. So I'm this kind of person who likes to just commit every 5 minutes, like you were hitting Command-S in Pages or something like that. I just like to save a lot. Now, that's cool. And honestly, if you are that sort of person, I don't think you should have any reason to want to stop. Just do it if that's comfortable for you. But sharing commits like that is a little bit antisocial. Because each one of those commits, let's just look at the log. Each one of those commits, you could see, just has a single file. That most recent one adds random 10, and then random 9, and then random 8, and random 7, and random 6. And it kind of looks like what you were trying to do was add 10 files. And you just happen to split that work up across 10 commits. And when you get into advanced Git commands like revert and like cherry pick, when we try to make sense of how those commands actually work in the world, it turns out that you want commits that are cohesive, and you want commits that are decoupled. So you want all of the things in a commit to have to do with one another, like you're telling one story. All right? You don't want to tell 4 stories in one commit. Like you're working on some feature, and you happen to notice some misspellings in the Java doc of a class totally unrelated to the feature. And so you have this commit that's moving your feature along. Oh, and by the way, here's a change to some other file with some misspellings to the Java doc. Okay, you're talking about 2 different things at once. If you did that in real life, you know, if somebody said, "How's your weekend?" and you said, "Well, it was great. We saw Iron Man on Sunday at this dinner theater kind of new thing in Aurora. And the Mayans were an ancient civilization that stepped out for a bucket of chicken one day and never returned. And after dinner, we came home and had a bottle of wine." People would be like, "Whoa, what?" You know, those are totally unrelated things. So don't do that in commits either. All right, cherry pick and revert will break, and those are very powerful commands if your commits are not cohesive. Likewise, your commits should not be terribly coupled. Now, there is always going to be coupling between time-ordered snapshots of the development work that you do. That's unavoidable. But that's dumb right here. I've got 10 things that are 10 things that really should be 1. So if you find yourself making commits like this, it's okay. You just need to fix them before you share them. And you do that with this rebase interactive command. So rebase interactive, you don't really give it a branch. You say, how far back in history do you want to go? And in my case, I'm saying 10 commits ago is where I want to go. I'm using that syntax that says 10 commits before the head, and what that's going to do is it's going to reconsider the head inclusive up to that commit exclusive. All right, so if you actually did the math, head tilde10 is title 20EB77F. 20EB77F is not going to appear in our list. So when I hit enter now, I'm going to get VI, confusing you. So if you don't mind, that wrapping is unacceptable. There, okay. The default Git editor pops up. So this is sensitive to the editor environment variable or a Git configuration parameter called core.editor. In my case, I have those unset, so I get the correct answer, which is VI or Vim. This is a recipe that interactive rebase wants to execute to rewrite those commits. It's listing them for me in the reverse order that log normally does. All right, so if you're paying attention, you'll see random 1, that's the oldest one, that's at the top. So oldest to newest, and it has an instruction in that first column. That instruction is pick. So the recipe I get will pick all 10 commits in the same order and not change them at all. So rewrite them all to be exactly the same thing that they are in the same order. It's kind of a no-op. But we've got at the bottom that little recipe recipe book where it says, under commands, I can pick, reword, edit, squash, fix up, or I can run a script. I'm going to make this easy. I'm not going to do a hideously complex rebase. Basically, I want to squash all those things into one. But I could, for example, say, when you get to random 5, if I made the command edit at random 5, it would stop the rebase and drop me back out of the command prompt. And I can do anything I wanted to that commit. It's completely mine to change. So using interactive rebase, you have absolute power to change history, as long as you haven't pushed. So let me make some changes here. I'm going to squash a bunch of commits. You just have to use the first letter, and that is enough. Squash, squash. You know what? I'm going to delete this line. I don't like the number 6. All right, squash and squash. All right, whoop. So you can't squash the top one, of course, because you got to squash into something. But that's going to take all of those now 8 newer commits and compress them into that one older one, and it's going to get rid of random 6 like it never happened. When I save, it flashes a little progress message there and brings me to the commit editor. It's basically glommed all those commit messages together. I don't really want them, so I'll just delete them, and I'll say random files 1 through 5 and 7 through 10. Save the file. Notice my vastly simpler history. Feature is now just a single commit. And that's a nice commit to share. What if I screwed up? What if I did the wrong interactive rebase? Where are those commits? I don't have them anymore. Well, I do have the reflog. And I encourage you, even before, probably just about done with that, even before you need the reflog, just start looking at it, before you actually need to run it. After you do something like a commit or a reset or a pull, or if you do a rebase interactive, make it a habit to study the reflog. Just check it out, because it takes a little bit of learning to know exactly where to go. Rebase, for example, makes a lot of noise. The most recent thing says finish, and then squash, 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 and then checkout. And you're like, I don't remember doing a checkout. What's up with that? Well, you do enough of this, and you'll see an interactive rebase always starts with a checkout. So just keep an eye on it. Watch it, and you'll learn. In my case, if I wanted to undo this, I would reset back to head at 10 or 73DA042. Reset hard to there, and now all my horrible work is back. But that's not what I want. I want to use the single step undo, which is there. Now it's back. So you got a lot of power to reshape what's in history. After you push it, it's harder. All right, if I had pushed these commits and then I rebase them, or I reset past the head and I try to push again, GitHub is going to say, or whatever upstream repository you're pushing to, is going to say, well, wait a second. The way this is supposed to work is you have a commit, and then you have another commit that's a descendant, and you have another commit that's a descendant of that. And as long as you give me new commits that are descendants of the commit I already have, well, then we're safe. I know you're not losing anything. But what if you give a commit where I can't go reach my head? I can't go back traversing parent links and get to my current head. That means you're going to cut these commits off. Now, in this case, it's fine, right? I know I have all the work I want. I want to push that stuff on top of whatever is upstream. But it's going to require that you force that, take this extra violent step and beat the thing down, give it a force push. And everybody else who pulls on that branch, their next pull will also require a force pull, exposing them to the risk of losing code. So really, you don't want to do this to stuff that you've already pushed, already shared, unless you really have to. If there's a good reason, then do it. It becomes a synchronous activity. Everybody on the team kind of has to get together and think about it at the same time and make sure that they're not losing work. So that's kind of big damage control mode, whereas this is just, I had this stuff locally and I'm sloppy and I want to make my work neat before I share it with the people that I work with because I love them and I want them to have a good time using my work. So with that, that's basically all we have time for. So we've seen how to make a commit without using add or commit. We've seen rebasing, we've seen reset and reflog, we've seen interactive rebasing. Those are things that, if you can really reason about how rebase works, and you can get around in the reflog and reset and things like that, you are way ahead of most Git users. And if you've got a little bit of insight into how those internals work, I think you're going to be, what I hope, is you'll be unlocked mentally to be able to think about this thing like a machine. As soon as you know some of those machine parts inside, it takes the mystery away. And you're willing to reason about it, and I really want you to be. It's not that hard to learn with just a few of these tips like this. So thank you very much for being here. I really hope you enjoy the rest of the show. Thanks.